A 75 milliliter solution of HCl with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molar CaOH2. What is the concentration of HCl in the original solution? So after looking at this problem, we want to point out the most important parts to remember. First, we're given that there's 75 milliliters of HCl, but we don't know the concentration. And this is titrated with 27.3 milliliters of CaOH2 that has a molarity of 0.157. Our first step is to write the equation. So as you can see right here, we have the equation that is balanced out that we can use to solve the problem. Our second step is to identify what we're looking for. And what we're looking for is the unknown concentration of HCl. So we're trying to find the concentration of HCl in the original solution, not the titrated solution. After this, we want to draw a picture to show what is happening in this whole problem. In our first beaker, you can see that we have the HCl, which is a strong acid, split up into H and Cl. And we have 75 milliliters of this, which is 0.075 liters, but we don't know the molarity of it. In the second beaker, we have the CaOH2, which is a strong base, so it is able to be split up into Ca plus 2 and 2 OH negatives. And this is because for every one Ca, there is a OH. And we have 27.3 milliliters of this, which is 0.0273 liters, and a molarity of 0.157. And we take this second beaker and we put it into the first beaker, which gives us the H2O plus CaCl2. And the CaCl2 is a spectator ion, so it won't be any further into this problem. So after this, we want to do step 4, which is solve the problem. We start off with liters of a substance, or we start off with the liters of CaOH2, and this is because when we're looking at the problem, we want to start with the substance that has more information. And as you can see up here, there's 27.3 milliliters, and it has a molarity of 0.157, and that's two things, but the HCl only has one thing, which is the liters given. So we start off with 0.0273 liters of CaOH2, and we have 1 liter of CaOH2 for every 0.157 moles of CaOH2. And then we have 1 mole of CaOH2 for every 2 moles of HCl, which we got from the balanced equation given up here. After solving this out, we get 0.00857 moles of HCl. And that is just the first part to solving the problem. The second part goes over here, which we see that moles equals molarity times liters, and that's important to remember. And we're given the moles of HCl, which is 0.00857, but we're not given the molarity, which is the molarity of the HCl in the original solution, which is our X. And we are given liters, which is 0.075 liters. After doing algebra, we find that 0.00857 divided by 0.075 equals 0.114 molar of HCl, which is our molarity in the original solution. So this is our answer, but some common mistakes that people make throughout this whole process is that you go into it thinking that it is a dilution problem, which is M1V1 equals M2V2, and that is not correct. You want to remember not to do that. Instead, you want to do the stoichiometry down here. Also, a lot of people forget to balance the equation, which over here you can see that we balanced it out, which helps us furthermore into the problem. Our third mistake that we find is that some people will forget to convert milliliters, which what we were given in the problem, to liters, which is what you need to use in the final solution.